Now, all of this discussion was done to prepare us to get to this point. So by far the most important use of organometallic reagents is their reaction with carbonyl compounds. This is why we did not study them reacting with alkyl halides in the last course of organic chemistry, organic one. So carbonyl compounds is the key. So let's look at an example here. So let's look at type 1. Remember type 1, which is aldehydes and ketones. So we have an aldehyde, acetaldehyde, and if we have an organometallic reagent, Grignard reagent, so let's bring it here to show you the mechanism and how the reaction will proceed. So we know this is delta positive. Electron poor. Oxygen is electron rich, so it's going to attack. As usual, you're familiar with this. So we're going to have remember the intermediate, the tetrahedral intermediate. Okay, so I hope you're understanding that this group right here, I'm going to label it, is that group right there. So, and make sure the attachment is correct. You can't attach it from the CH3. That violates the octet. So that's a big, big mistake. So this is what we said, what we call the tetrahedral intermediate. Now, if you remember from the last discussion with the reduction and leaving groups, do we have a leaving group in here? Can those electrons come down from the carbonyl and kick something out? The answer is no. There are no leaving groups because H or R, an alkyl group, are not no leaving groups. So the reaction stops here. After, of course, protonation. So you're going to just simply add water. That's what step 2 is about. And we end up with an alcohol. Now, why is this reaction important to organometallic reagents? Why? It's for a very simple reason. Carbon-carbon bonds are the most important, at least in this discussion. So this right here is a new carbon-carbon bond. This is very, very important. You build molecules, bigger and bigger molecules, by creating new carbon-carbon bonds. Because remember, the majority of organic molecules have what? Have carbons in them, carbon atoms. So they're organic, they're carbon-based. So also with organolithium reagents, the same thing can happen. So you should pause and draw the product. Okay. And then, of course, with H2O, we know that it becomes protonated. There are no leaving groups here. No leaving groups. So you should always be in the habit of, get in the habit of recognizing whether you have leaving groups or not. Very well. Now, sodium acetylide reagents can also add to ketones and aldehydes. So there's no new discussion here, although this is not an organometallic in the sense like the ones we learned from organomagnesium, lithium, or copper, but nevertheless, they still react the same way. So you can attack here. So I just drew it a little bit differently here. So we just added our group here. And of course, with water, then you would basically protonate this. Let's see if I have space, enough space to draw this. Maybe I'd have to draw it down here. Boy. Right here. And again, we have no leaving groups, as we said before. All of these reagents react with aldehydes and ketones to form new carbon-carbon bonds. Carbon-carbon bond forming reactions are very important in organic synthesis.